Good to see you, everybody. How you doing? How you doing? Hey, welcome, ladies and gentlemen, boys and girls, fans of math of all ages. We're talking about derivatives for real, and we're finding derivatives by the definition of the derivative. Later today, we're going to learn some properties, I guess, which will feel significantly shortcut of an approach, but that's okay. So here we got our function, and I'm looking for an equation that will represent the slope of this function at all times. And notice, I think you guys would agree that the slope of this line is always 7. All right, so even just kind of like general analysis, that would seem to make sense. But now let's do this by the actual definition of derivatives. So f prime of x, I'm going to write the definition here just so it's here at least once in this video, is f of x plus h minus f of x. So that's kind of like my y2 minus y1 over an x2 minus x1 ends up simplifying to being just h. Oh, I skipped a part. What did I skip? The part I always forget. It's the limit as h approaches 0 of this, and that's an h and not an n. So as h goes to 0, and clearly this is undefined for when h is 0, but that doesn't matter to us. We're looking at what it approaches.
In the book, it had like f prime being f apostrophe x, which was weird. It was an f1x.
This isn't a 1. Yeah, actually this is an apostrophe. That's not a 1. Just, yeah. I mean, I suppose that does look like a first degree. But yeah. Yeah, you can even see it's like an apostrophe there. So yeah, my apostrophes, and then you can have f double prime. Yeah. So, yep, that's a very good distinction, that is not the numeral 1. That is a little apostrophe thing. I don't know. So, let's figure this out. So, what is f of x plus h? So, f prime of x is equal to the limit as h, not x, h approaches 0, of f of x plus h would be 7 times x plus h plus 4 minus of f of x, which is just this whole thing, so 7x plus 4, all over h. And now let's simplify, so limit of 7x plus 7h plus 4 minus 7x minus 4 when you distribute all over h. And then we've got 7x and minus 7x, and 4 and negative 4 cancel out. And I get the limit of 7h over h. And you can see that I don't even need to factor an h out of the numerator. Those h's cancel out. And what happens is I take the limit as h approaches 0 of 7. Well, 7 is approaching 7. I'm pretty sure. So f prime of x is 7. Meaning, if I was to graph the original function, 7x plus 4 has a y-intercept of 4 and a slope of 7, up 7 over 1, up 7 over 1. So it's a very steep line, something like that. And if I graphed the derivative is what Khan Academy would say. He'd say like the same last third of the line over a couple times. That's what he does. This would just be a horizontal line at 7. Okay? Right, where this is occurring at 7. And that makes sense because if I found the slope anywhere on this line, oh, that's a slope of 7, that's a slope of 7, that's a slope of 7. So yeah, it's 7 all the time. So this occurs at 7, and there's our line. Now question, what if I had a line, what if I asked you this? What if g of x was 7x minus 20? What would g prime of x be? 7. Right? And it turns out that the y-intercept, so let's say this intersects way down at 20, there's my g of x. It would still, right, it's the slope that matters to us. The y-intercept actually has no effect at all, and we'll see that coming into consideration, the fact that the y-intercept is negligible when it comes to derivatives. we'll see that come into play a lot when we're considering antiderivatives. Question, comment, observation.
Why do you use G of X?
F of x and g of x, I don't know, E, F, G. Those are usually function names. H of x would be next.
They don't use vowels.
A of x could be a function representing acceleration. And actually, oh man. No, I'm not even, I can't even. No, I can't drop this bomb on you yet. It's way too big. Your world of physics, when thought through the perspective of calculus instead of trigonometry, it simplifies things incredibly. Like there's a relationship between a positional function, velocity function, and an acceleration function that are just really cool. But I just want us to try to get used to the idea of derivatives right now, the idea that you have a graph that represents the slope of another graph. It's kind of an intriguing thought. That concept takes a little while to get used to. And that's what I'm focused on. I mean, really, with this whole little intro to calculus, that's what we're looking for. So I'm going to do 18. And actually, take a look at 14. The slope is 2 all the time. 16, the slope is negative 3 all the time. 17, the slope is negative 4 all the time. So finding the derivative of a linear function, right, I'm assuming you guys could kind of come up with your own shortcut for that, right? It's not that bad. Right, because we know y equals mx plus b, and the slope's the same for the whole time. So that one ends up working a-okay. Actually, I might end up doing 18 and 19. I might, because it will actually build way good into our shortcuts that we're learning today. So, once again, f prime of x. F prime of x is equal to the limit as h approaches 0 of f of x plus h all squared. Nope, not all squared. So 2 parentheses x plus h squared plus 5 parentheses x plus h. So do you guys agree that this is f of x plus h, where I've replaced both of the x's with x plus h's? All right, that's what f of x plus h means. And I'm subtracting f of x. What's f of x? Oh, it's this. I already knew what that was. So that's 2x squared plus 5x all over h. And literally, this is the slope formula. It's y2 minus y1 over x2 minus x1. And my points... Right, because it would have been x plus h minus x, and then the x's just cancel out. It's just h, right? And my points of x2 and x1, the difference between them is h, and it's becoming negligible, where h is approaching 0. So they're getting closer and closer, so much that it no longer is two separate points.
So you plug in x plus h
in for both of those x's. Yep.
And then you plug in that into the
f of x. Right. Yep.
Equation.
You got it. You got it. So let's simplify. So this would be 2 times x squared plus 2xh plus h squared, using a pattern there, plus 5x plus 5. That sounds like how you'd pronounce that. 2x squared minus 5x. Don't forget to distribute that sign all over. Oh, that's a little bit too...
You're wrinkling or not.
There we go. And then 2x squared plus 4xh plus 2h squared plus 5x plus 5h minus 2x squared minus 5x all over h. And of course, I forgot my limits. Lim. And once you've defined your limit of what is approaching what, I'm fine if you abbreviate it as just lim from then on a little bit. Although a proper calculus teacher or the AP Calc exam would probably not be cool with that. I don't know. We're using our own lingo, our own jargon here. We're doing math on the streets is what we're doing. So just be cool, guys. So let's see. What do I got? 2x squared minus 2x squared plus 5x minus 5x. And what I'm left with is I've got a 2h squared plus 4xh plus 5h all over h. And notice that each of the terms in the numerator have an h in it. You could just cancel out an h out of all three of those. Or you can factor out an h, and I forgot my limit again. Guys, dropping the limits. I'm trying to figure out like the sideways view of equals lim, what that would be as an emoticon. And then like I imagine it'd be kind of like a frog-ish thing.
Or if you just get rid of like that, you just have the I and the L.
Yeah, intriguing. Anyways, equals. So let's factor out the h. So that's h times 2h plus 4x plus 5. Right? All over h. Those h's, sorry if my h's begin to look like n's. So the limit, those h's cancel out. So I get the limit of 2h plus 4x plus 5 as h approaches 0. So 2h is approaching what?
0.
0. 4x is approaching 4x. And 5 is approaching 5, right? X is not approaching 0. X is remaining as any value of x from the original function. Okay? So I end up getting f prime of x is equal to 4x plus 5. 4x plus 5. So that's an interesting thing. I don't know if you picked up on that. So the derivative of a linear function is a constant function. The derivative of a quadratic is a linear function. And the derivative of a cubic is going to be a quadratic function. I think I've got enough. Yeah, so it seems to be a degree less.
But then with quadratic, it gets kind of funny because you start multiplying by different.
We'll have to figure out some of the stuff. But notice it is 1 degree less. So there's at least, we've recognized that pattern. All right, so if I want to find the derivative of this, derivative, f prime of x, this one's going to be Gimundo. The limit as h approaches 0 of x plus h cubed plus 5 parentheses x plus h squared. At least they didn't have a linear term here. They saved us a little bit. Equals the limit of, what's this? What did I forget? Oh man, that's right. Minus f of x. There we go. X cubed plus 5x squared plus 6. Thank you kindly. So there we go. I forgot my f of x. Classic mistake. So this is what? X cubed plus 3x squared h plus 3xh squared plus h cubed. Is that first thing expanded using the binomial theorem?
Or Pascal's triangle.
Plus 5 parentheses. Well, x plus h all squared would have been x squared plus 2xh plus h squared. I'm going to distribute the 5 all in one step just to save us a little bit of time. What did I do wrong? 5h squared. And then minus x cubed minus 5x squared minus 6. All over. That's a lot of terms.
All over h.
All over h. That's what I teach my son Everett. I'm like, h says, and then he goes, and it's awesome. He learns stuff. I'm impressed with him.
He's going to be doing calculus before he can even like.
He might. Actually, my Uncle Dan, spelled with D-A-N-N, whenever he sees me, he's like, do you know what the derivative of x squared is? And maybe you'll know the answer to that question. Maybe when Uncle Dan asks you that tonight, you'll be able to answer him. Maybe I'll just give you guys his Facebook name. Actually, it's D-A-N-N Waddy. I suppose it wouldn't be that tricky to find out. He's a paternal uncle. And you could just mass spam message him the derivative of x squared is. That would be kind of amusing, just spamming my uncle with a bunch of calculus facts. I kind of find this amusing actually right now. But anyways, let me keep going.
Side quest.
Side quest. That'd be hilarious. Well, he'd be proud of me that I'm teaching you, so he'd be happy. All right, I see an x cubed killed off by an x cubed negative. 5x squared and 5x squared.
6 and 6.
Did I lose my 6? I
Yeah,
did.
you did.
Ah! There's a plus 6 hiding right here. You didn't see it.
Oh, there it is. Nice.
There it is, yep. It was written with the black ink, so it didn't show up well. Okay, and notice all of my remaining terms in the numerator have at least one h. But I'll write them all out again, just for fun, because I know you guys would love to see them all written out. So I'm going to write it in standard form.
Interesting definition of fun.
Yes. H cubed plus 3xh squared plus 5h squared. Let's see. Plus 3x h squared.
No, 3x squared h.
Oh, sorry. Yep, and then plus 10xh. Do I have? So that's in decreasing order by h degree, I believe.
Yes.
And then, hey, I could factor an h out of all of those.
That's handy.
H factory. H squared plus 3xh plus 5h plus 3x squared plus 10x. All over h. Huh. Huh. H says, huh. So, the limit as h goes to 0, I'm not going to write that all out again. We're all getting tired of it. What does h squared approach?
0.
0. What does 3xh approach?
0.
What does 5h approach?
0.
So this is approaching 3x squared 10x plus 10x.
All over 1.
So there's my derivative. And then if I asked you what was the slope at a particular point, the slope of a tangent line or slope of the curve, you would just plug in x. Yeah, so if I wanted to find out, pardon my sneezes, if you wanted to find out the slope of this curve at x equals 1, you would plug in 1 into the derivative. 3 times 1 squared is 3, plus 10 times 1, 13. The slope is 13 when x equals 1. That's the slope of a tangent line. Craziness. And then you could actually even find the equation of the tangent line if you were really interested, because once you know the slope and the x-coordinate of the point that it passes through, you could also find the y-coordinate and then find the equation of slope in that point, find the y-intercept. Bam. Good stuff. So, so that is how to find the derivative the long way. Let me actually see if you guys can spot some interesting stuff here.
2 squared is 4.
2 squared is 4. Okay, so that's an interesting... 2 squared is 4. That might be a case. And then what about this to this?
Divide both of them by x.
Divide both of them by
Divide the whole binomial by x.
Not quite. Well, let's see if that theory applies on the cubic. How would I get from here to here? Multiply by 3.
Multiply by the degree.
Multiply by the degree, and then what happens to the degree?
It goes down by 1.
It goes down by 1. Let's see if that worked up here. So if I multiplied this by the degree, 2x times 2 is 4x, right? Which 2 squared, I agree, is also 4, but that's a difficult pattern to recognize because 2 squared is the same as 2 times 2. And notice the degree went down by 1, right? 2 became 1. All right. Actually, what about multiplying by the degree here? 1 times 5 is 5, and decrease the degree by 1, you get x to the 0th, which is still 1. Okay. Interesting. Let me delete that yellow line. And notice for my quadratic term here, 2 times 5 is 10, and decrease the degree by 1.
Is that how easy it really was?
Yeah. What about what's the... Right, that's x to the 0, so 6 times 0 is 0, and then x to the negative 1, so it'd be 0 times 1 over x. I don't know. That's
0.
a little weird. It's 0.
Which is 0 over x.
Right. The derivative of a constant function. Yeah, actually, let me ask you that side question. what if g of x is equal to 10? So it's just a horizontal line at x equals 10. What is the slope of that line?
Undefined.
Of a horizontal line?
0.
0. So it would be 0 all the time.
Vertical is undefined.
So the derivative of a constant is 1 degree less than that. That's just, that's 0. Yeah. So hopefully you can spot some patterns. That's actually going to help us with our next lesson starting in the next video. Yay. Bye, Internet.